Welcome back to my channel, everyone. 3 tips here. 14K material. And you can see we've got 48.1 grams of 14K. 10K stuff. And you can see we've got 10.8 grams of 10K. 18K chain. And you can see we've got 13.1 grams of 18K. And then we've got this gold bar that we refined out of our last video where I burnt the chloroauric acid solution. It's got a little bit of frost on the surface, so we're going to refine it in this video. And we've got 42.1 grams of 24K. I've calculated that I need 228 grams of sterling silver to refine this batch. But instead of using sterling silver, this time what I think we'll do is we're going to use some pure silver crystal from my electrolytic silver cell. We're going to put in 228 grams of pure silver crystal and inquart this gold with pure silver crystal. $228. $13, $16. All right, that should be enough. 225 grams of pure silver crystal. Now we're going to take this out and quart the Karat Gold with the pure silver crystal. Pour it into some water to make some granules. Here's our look at our inquarted gold. It's been inquarted with pure silver crystal. And I normally don't do this. Just doing it for the video. Because what I'll have to do now, the silver that I added in here It's already been through the silver cell. Now I'm going to have to pour it back into my silver jar, cement it out with copper, melt it, and put it back through the silver cell. And that's why I don't like using pure silver crystal for inquartation. I'm going to add some distilled water. Plus, I'm going to lose my color indicator. Pure silver crystal, when dissolved in nitric, is clear and colorless like water. Sterling silver, however, has copper in it, and that copper turns the solution blue as I process it with the nitric acid boils. And I can tell when the blue color disappears out of these nitric boils that I've completed the boiling process and got all the silver and base metals removed, because there will no longer be any blue color in my liquid. And I lose that when I use pure silver crystal. You're probably saying, in Street Tips, why is that solution turning a blue color like that? And the answer is Karat scrap has copper alloyed with it, and so that's why it's turning blue. This will be the first nitric acid boil. Nitric boil number 1 is complete. I'm going to pour this off into my silver jar. The silver jar has sterling silver in it, and it will consume any excess nitric that's left in this solution. Here's a look at the gold down in the bottom of our beaker, and quarted with pure silver crystal. Add some more distilled water, put it up on the heat. Now we'll add some more nitric, and this will be nitric acid boil number 2. Let's pull this down off the heat for a second. Reach down in here and get some of our solution. And we're going to test and see if we're getting any silver chloride forming in here. See if we're still pulling silver. And I do see silver chloride forming in the beaker. So that means we're still pulling some silver out of here. Let's get rid of this solution. Pour it off into the silver jar. We're going to rinse the gold out real good with some distilled water. I'm going to add some more distilled water. Put it back up on the heat. Now some more nitric. Number 6. It's been boiling for about 45 minutes. Let's go ahead and pull this down now. Let it cool off. Let's get in here and check for the presence of silver. Just get a little of the solution in a beaker here. Now what I'll do is add some hydrochloric acid. If we got silver in here, it should form a cloud of silver chloride. And I don't see a whole lot of silver chloride. It's got a little yellow tint to it. That's just aqua regia. I think we're good to go. I think we've got all the silver pulled out of here now. Let's go ahead and pour this off. Rinse this off now with some distilled water. Add a little bit of distilled water to this beaker. We're going to boil the gold in some plain distilled water now. Been boiling in water for about 20 minutes, I guess. What we'll do is pour this off. Here's how the gold looks down in there now. Should be very close to 3/9 fine, just like it is right there. Now what we'll do is set it up here on the hot plate, and I'll add some hydrochloric acid. This is about 85 grams of gold or so, so we'll go with 300 up to the 300 milliliter level with hydrochloric acid. I'm going to try some 29% hydrogen peroxide to dissolve the gold on the initial dissolve here. Cover this up. Going to start a flow of hydrogen peroxide down out of our delivery apparatus. Just going to drip it in a little at a time. Let's see if we can get this gold to go into solution. Add some heat. It takes a lot of heat for this reaction. I've got just about everything to go in solution. Let's move this stuff out of the way. Get this thing out of the way, it's hot. I think there's a little bit of gold left down in the bottom of our beaker. Not much. A few crumbs, a few little chunks. What's left down there. We'll add these last few little crumbs down into the waste container rather than try to dissolve them and get them included with this. We'll just recover it later when we do the waste container. The solution is slightly cloudy. Here's what's in the filter. And so what we're going to do is we're going to pass solution a second time through the same filter. Once this filter gets loaded up like that, then it will filter out finer and finer particulate. We should be able to get it to clear up by passing it through the same filter a second time. Here we go. That second pass through the same filter has cleaned the gold up real nice for us. Let's transfer our gold solution into this beaker. It's the same beaker we did the other reaction in earlier. I've cleaned it out, washed it out real good. Here we go. We're going to do the first precipitation using some stump out. This is sodium metabisulfite. Here we go. First spoon going in. I just realized I didn't get any Astanis test, so we can still do that now. Get a little solution on this piece of filter paper, put some Astanis on there, and you can see that dark stain means gold in solution. Let's put another spoon of SMB in here. That's 2. There's 3. There's about 85 or 80 grams of pure gold in here. There's some white foam on top. I think we got it. Some hot distilled water. What we're going to do now is rinse the gold off. Now we'll add some hydrochloric acid. And I'll set it up on the heat, and we'll boil this gold in hydrochloric acid. While I'm waiting for that to boil, I've got this flask here that's still got a little bit of gold in it in the filter. So what we'll do is hook it back up to the vacuum and pull the rest of the gold through. I didn't want to pull it through and pull some silver chloride down into the main solution, so that's why I left it separate. Got that all pulled through. That's what's left in the funnel or the filter. Now we're going to pour off the boiling hydrochloric acid and rinse the gold with some more water. Here's the gold after first refining. Let's set it up on our heating pad here. We're going to refine it again. I'm going to add hydrochloric acid. I'm going to add some sulfuric acid, just a little bit, to take care of any lead that may be present. Now let's add some heat. And I'm going to start dosing the hydrochloric acid and gold in this beaker with some nitric acid. And we're going to try to dissolve this gold a second time. Here we go. That's 1, 2, 3, 4, 5, 6, and 7 milliliters. Well, actually about 7 3-milliliter doses of nitric acid. I think we've got everything to go into solution. I'm going to pull this down off the heat now and let this cool down. Let's get some SMP in here and get this precipitated out. It's going to add some stump out right on in right now. I think we got it all. I've allowed this to settle for about 20 minutes. I'm going to pour off the waste and rinse it with hot water. Now let's get our gold in this dish. We're going to try to dry it off before we melt it this time. Of course, something's going to have to stick a little bit up in there. Let's get the water out of here. Alright, let's pull up a burner here. Stick our gold up here. Cut it down on low and dry it off. Here's our pure gold sponge. It's just beautiful to look at. High purity gold powder. Just absolutely stunning. Beautiful. So now what we're going to do, we're going to put it in a melt dish over here. See if we can get it down in here. A little bit at a time. Let's take our pure gold powder in this melt dish. Look at that stuff, man. Looks good enough to eat. We're going to melt this an ingot now. Oh yeah, look at that thing, man. Good Lord, it's beautiful. Oh, look at this one here. pretty. Nice shape to it. No traces of contamination. Beautiful, beautiful. 3/9 fine, pure gold bar. Let's see, we're expecting 84.4 grams. What's our actual yield here? We got 83.5 grams. This thing is just really, I'm really pleased with this thing. I can see my reflection in it. And we started on this at 6:30 a.m. It's currently, I think it's about 8 o'clock p.m., maybe 7:30. So it took 13 hours to refine this pure gold bar. And it's stunning. All right, this will conclude the video. Thank you for watching.